An ecological system is vulnerable to destruction from the introduction of plants or animals outside that system. For example, when a non-native plant is introduced into a new area, it usually does not have its growth checked by the environment. With unlimited food and no predators, the non-native plant grows exponentially, quickly covering, killing, and replacing the endemic native plants. Such a plant is the water hyacinth, which has been called the worst aquatic plant in the world. Wow. It's native to South America, but is now part of the rivers, lakes, and streams in most of the southern United States. The water hyacinth is said to have been introduced into the United States in Louisiana at the World's Industrial and Cotton Centennial Exposition of 1884 and 1885. A Floridian went home with water hyacinth plants and later released them into the St. Johns River. From this beginning, water hyacinths now cause problems such as forming floating impenetrable mats of floating vegetation. These block boat traffic, prevent swimming and fishing, and prevent sunlight and oxygen from getting into the water. Perhaps the worst effect of the water hyacinth is the reduction of biological diversity in waters in which it inhabits. You know how sometimes we do word problems and they're mostly just made up so that we can have some math to do from those word problems? This is real. It's real. Okay? Water hyacinths are quite beautiful. If you search it up on the Google or something like that, you can see how beautiful the plants are. Okay? I would do it now, but couldn't see it on the video or just, you can either trust me that they're beautiful or go look them up later. Is that fair? Okay. Water hyacinths double in 6 to 18 days. Okay. For the purposes of this investigation, consider that the number of water hyacinths will double in 12 days. Why are we choosing 12? That's between 6 and 18, right? Okay. Also assume that there is an unlimited food and that there are no natural predators. Suppose 4 water hyacinths were put into the St. Johns River. In question number 5, we're going to make a table to figure out that number. But before we do that, I want you to determine within your group right now the information from this problem that's going to be important in figuring out that number. So talk real quick in your group. What information is going to be important? All right, somebody tell me one thing they think is going to be important. Double in 12 days. I'm going to underline that. I would recommend that you do that as well. There are 4. We're starting with 4, right? There's other information that's also important, but maybe not necessarily in determining the number. What information is also important, but maybe not in determining the number? Unlimited food, no predators. Everybody understand? Okay, after 4 doubling periods, how many days will have elapsed? Well, how do we figure that out? So we start with 4 doubling periods. And he said each doubling period is 12 days. What do you think I should do with 4 and 12? Multiply them. What is 4 times 12? So to answer the question, 48 what? Days. Now notice what it says after the question. Be sure to justify each answer in this investigation. It's not going to say that again, because it's not going to say that on every problem, but it wants you to justify, and I want you to justify every problem on this page. Have we done that? How did we do that? Yeah, we wrote words, right? Isn't that justifying what we did? If I come back and look at this in a couple days, am I going to know how I got an answer of 48 days? Because I showed my work, right? And I justified it with the words and things like that. Okay? After 96 days, there will have been how many doubling periods? How are we going to do it? There's 12 days in a doubling period. So what do I do with those 96 days? So divide it by 12, but 12 is the days in doubling period. It's supposed to say days. Does it say days? Kind of looks like it says dogs. You understand that says days, right? Okay, sorry. What is 96 divided by 12? So I think he knows that off the top of his head. If you don't know that off the top of your head, what should you be doing right now? You should be getting out your calculator so that you can participate in the rest of the lesson, please. So 8 what? In 60 days, how many times will the water hyacinth population double? In 60 days, the water hyacinth population will double. How many times? How do you know? So 60 divided by 12. Okay. What about 120 days? How should we answer that question? In 120 days, the water hyacinth population will double. How many times? 10 times. And how do we know it's 10 times? 120 divided by 12. Okay. Because this is exponential, can we say it's just double this one? Not necessarily, right? We want to make sure that we are showing our math for the way we know it's going to work. Just so happens it does in this problem, but we have to be careful, okay? Also, there were some issues earlier with spelling the word hyacinth. Is that a word you just know how to spell? It's also not a word that I know how to spell, but it's also right here. And you can just look up here, right? Okay. Some people know how to spell it. Some of our people did amazing at UIL yesterday, and I think we got first, third, and fourth. First, second, fourth, something like that, and spelling. We did amazing. Might have been all 4 of our people that placed. I don't remember, though. Do you remember? No? Okay. It wasn't you? Okay. Complete the following table to show the number of water hyacinths from these 4 at any given time. Okay? So 0 days, which would be 0 doubling periods. Everybody okay with that? Why is this 4? We started with 4. Okay? After 12 days, because that's what we decided, right? They said between 6 and 18. We decided it on 12. After 12 days, that was 1 doubling period. So that would be 4 times 2. Why 2? Because it doubled. Does that make sense? So exponentially, that would be 4 times 2 to the first. Can we now go backwards and see why this is 4 times 2 to the 0? Because what is anything to the 0 power? 1. And 1 times 4 is 4, right? 2 to the first power is 2. 2 times 4 is 8. After 1 doubling period, did the total number double? Yes. Okay. So after 24 days, that should be 2 doubling periods. How do we get from the number of days to the number of doubling periods? Divide by 12. Okay. Could we get from the number of doubling periods to the number of days? Multiply by 12. You okay with that? Okay. What's the process column for 2 doubling periods? What do you think that looks like? 4 times 2 times 2. Because it's what it was before, doubled, right? Well, exponentially, what does that look like? 4 times 2 to the second power, or squared. Well, what is 4 squared? Or what is 2 squared? What is 4 times 4? Now, that's going this way across the table. Does that still work if we go this way? Because what's supposed to happen every time right here? As long as we're doubling like one time, right? What's happening right here? It should double, right? Okay. After 3 doubling periods, how many days have there been? 36. And we talked about that just a second ago, right? How to get from doubling periods to days. What does the process column look like? Okay. Somebody different? What's the exponential version look like? 4 times 2 to the third. Good. What is 2 to the third? What is 8 times 4? So once again, that matches going across here. Does it match going here? It does, right? Because double, double, double. After 4 doubling periods, how many days has that been? 48. Somebody else tell me what the process column looks like. How many 2's are there? Okay. Well, that seems like a good way to figure out what the exponential version looks like, right? How many 2's are there right here? 4, so this should be 2 to the 4th. Good observation on that pattern. What is 2 to the 4th? 16 times 4? 64. After 5 doubling periods, how many days has there been? Somebody different? What does the process column look like? How many? So what does the exponential version look like then? Very good. And what is 2 to the 5th? What's 2 times 2? 4 times 2 times 2? 16 times 2? 32. What is 32 times 4? Now, how many of you knew what 32 times 4 was versus how many of you doubled 64? Shouldn't it be the same though? Right? All right, somebody different. If we have 6 doubling periods, how many days is that? 72. Good. Somebody different. Process column. What's it look like? Okay. 1, 2, 3, 4, 5, 6. Which helps me with my exponential version. 4 times 2 to the 6. Excellent. What do you think goes here? Did you get it by saying 2 to the 6th times 4, or did you get it by doubling 128? Because that's easier, right? Okay. What if there's 10 doubling periods? How many days is that? 120. What's the process column look like? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 4 times 2 to the 10th, which is? Very good. So it's all well and good when there's numbers to deal with, right? But what if there's not numbers we can deal with? What if our number of days is n? How did we get from our number of days to the doubling period? We divide by 12, right? So if I tell you it's n days, how do we get to the doubling period? What did you just tell me to do? So n over 12. How is the doubling period related in any way to the exponential version? So the doubling period is the exponent. Is that what you're saying? Does that make sense? If it's doubling, that's why there's a 2, and this is how many times it's doubled. Yes, the exponent? So how many total water hyacinths are there if the doubling period is n over 12? 4 times 2 to the n over 12. Very good. About how many days would it take for there to be more than a billion? Let me underline that. A billion from the original 4. Do you want to continue this table until we can find a billion? Is there a table that we can look at that will do it for us? Oh, why don't we do that then? Why don't we start a new document in our calculator that is a graph? What equation am I going to put in here? It's just being rude. 4 times, see what I'm talking about? It's being rude. Four times 2 raised to the x divided by 12. Now when I go look at the table, what am I looking for in the table? Where? In the y's? Does it make sense that at 0 it's 4? Because why? I started at 4. Does it make sense that at 12 it's 8? Because after one doubling period, shouldn't it have doubled? So what I'm looking for in the y column is a billion. Is that what you're telling me? Okay. I just have the down arrow. I'm just holding on to the down arrow. I'm going to have to start paying attention eventually, right? Okay, where am I right now? 10,000?
Yeah, a little bit.
I got a little bit. Okay, 10,000. 100,000. What's this? A million. Okay, what's this? 11 million. So 100 million. What's that? That's a billion, right? 1, 2, 3, 1, 2, 3, 1, 2, 3. That's my answer. Why can I say that? What's the very first word of the question? Nope, the very first word of the question. Yeah, about. The very first word is about. So about how many days is it going to take? About 335 days. Now, we have to have our justification here, though, right? How did I figure out this answer? How did I figure out this answer? I used the calculator. Table on the calculator. I just want to be able to remember when I go back to look at it, right? Remember where the answer came from. I need to make sure that I'm very clear here, though. Make sure you're very clear here, okay? About how many days would it take for there to be a billion? A billion. 335 days is not even 1 year. Not even 1 year from when you put the 4 water hyacinths in the water, and there's a billion. Yikes. Using your formula, how many water hyacinths would there be after 3 years? Let's ignore leap years, okay? So how are we going to do this? Using which formula are we talking about? This one? Okay. So what goes in for n? The number of days, right? What asks for 3 years? So 365 times 3, that's going to be our first justification, right? Figuring out where we got that number. What is 365 times 3? 1095. So 4 times 2 to the 1095 divided by 12. Power. What do you get? What did you get? Yeah, I actually want you to do it. 1 point what? I got 8. Is that okay? Times 10 to the 28th water hyacinths. To me, that's not a real number. Can I show you what the number is? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Billion, let's see, million, billion, trillion, quintillion, wait, quadrillion, quintillion, sextillion, septillion, octillion? Do we do that right? What else could we write over here? A lot. It's a big number. After 3 years, there's this many water hyacinths. That's a number I can't even really fathom in my head. It's just so much. Okay? Suppose growing conditions for water hyacinths were actually ideal, and instead of doubling every 12 days, they actually doubled every 6. It told us in the beginning it could be anywhere between 6 to 18, right? What if it was actually 6? Rewrite your formula so that you start with the same 4 water hyacinths and double every 6 days. What does that look like then? 4 times 2 to the n over 6. Got it? Using this new formula, how many water hyacinths will there be now after 3 years? Well, we already said 3 years is 1095 days, right? So 4 times 2 to the 1095 over 6 power. Do that in your calculator. Unless you can do that in your head. I don't know. I'm not trying to judge you. 3.47. If we're just going to 2 decimal places, 3.47 times 10 to the 55th water hyacinths. This is already what the number looked like when there was 28 places after the first digit. I am not going to try to write it when there's 58 places after the first digit. It's basically double this. There's double as many zeros as there was here. Don't challenge me, weirdo. Do you think that this formula will accurately predict the total number of water hyacinths indefinitely? Or Are there environmental conditions that might limit it? What are they? Size of the lake. Doubling periods. What? Maybe. But remember at the beginning we talked about that there were no predators, right? But maybe, we'll get to that in just a second. Like we run out of oxygen, so we all die. Okay, that could be possible. Maybe a disease might happen to the plants. If you were the environmental scientists in charge of reducing the population of water hyacinths, what would you try? Burning them. Okay, so I'm gonna write it down because we're brainstorming here. Okay, burn them. But I do want to remind you that you are an environmental scientist. Have you ever seen a fire? What comes from fire? Smoke. You think smoke is going to help the environment? Heck yeah, of course it will. Oh my goodness. All right, what else? What else would you try? Pesticides. Pesticides. Is that how you spell pesticides? Okay, so we're going to dump pesticides into the rivers to kill the plants. Say that again. So you want to add a predator? Add a predator. What kind of predator are you going to add here? Do you have any ideas? So we could go to South America and get the predators. 'Cause remember, that's where they're from, right? And bring it. Oh, so we're adding another invasive. Awesome. Okay. Shoot them. We're going to shoot the plants. Shoot them. Relocate them. Yes, unless we move them all to South America, which is going to be very cheap, isn't it? Okay. So dry up the lake. Is that what you're saying? Dry up the lake. Eat them. What do you mean if? Lots of people watch my video, Matthew. I did that on purpose. Are we good? Is this a good start anyways? Use a rake. Okay. The same way that non-native plants can destroy ecosystems, non-endemic animals can do the same. In 1859, 22 rabbits were imported to Australia from Europe. Before this, there were no rabbits in Australia. The rabbits found a land with plenty of food and no natural predators. Why are there no natural predators there? They've never seen rabbits before. They don't know what they are. Okay? Soon there were so many rabbits that they were destroying the island. The island we're talking about is Australia. Not some island in the middle of Lake Clyde or something like that, right? It's a giant island. Okay? In Australia, the rabbit population was doubling every 6 months. Determine, first of all, in your group, the information that we're going to need in just a minute to write the equation. Figure it out. You know what to do. Underline it, right?
Yeah.
Underline it. All right, what's important? 22 rabbits, doubling every 6 months. What's also important? Okay. Explain how to calculate the number of years elapsed for 4 doubling periods. Explain how to calculate the number of years after 4 doubling periods? How many doubling periods are in a year? 2 doubling periods per year. And how many years has it been then? Sorry, 2 doubling periods per year. What are we going to do with the 2 doubling periods per year? Multiply it by what? But there's already 2 in a year. So times 2. Right? How many years is that going to be? 2 years. There's 2 doubling periods in a year times the 2 will give us 2 years. Because we need to get to 4 doubling periods, right? Okay. How many doubling periods will have elapsed after 18 months? How did you get there? So 18 6, because that's how many months, right? Equals how many? 3 what? 3 what? How many times has the rabbit population doubled after 4 years? How many doubling periods in 1 year? 2. So 4 times 2? 8 what? How about just 8 times? Because it asks how many times it doubled. Is that okay? What about after 7.5 years? 7.5 times 2? So how many times? 15 times? We got a table to complete. Can we do this quick? Let's do the months first. Can we do that? How do we get from the growing periods for these rabbits, from growing periods to months? Multiply by 6. So 2 times 6 is, 3 times 6 is, 6 times 6, 8 times 6, and 10 times 6. What's the process column going to look like? 22 here. What's the next one going to look like? 22 times, we're still doubling, right? Now we're calling it a growth period, but in that growth period, what's happening to the number of rabbits? It's doubling, isn't it? Okay. So 22 times 2 times 2. We're about to see a lot of 2's, so I hope we can handle it. Making sure, let's stop right here and making sure we got our exponential version. Exponential version of this one's the easiest to see. 22 times 2 to the first, right? 22 times 2 to the second. 22 times 2 to the third. 22 times 2 to the fourth. Let's go back up to the very first one then. What do people always forget? The 0, right? Now 22 with how many 2's after it? 1, 2, 3, 4, 5, 6. I'll get this finished and you can watch the rest of it. The rest of these questions are what you're responsible for when you get here tomorrow. Okay? 22 times 2 to the 6th. I'm finishing it right now. 22 times 2 times 2 times 2, 3, 4, 5, 6, 7, 8. I'm going to finish the table on the video. You're responsible for these questions down here. Yeah, you're going to be fine. 22 times 2 to the 8th. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 22 times 2 to the 10th. So total rabbits is 22. 44, 88, 176, 352, 1408, 5,632, and 22,528.
Okay, your camel referred to yourself.